Why are biomarkers the holy grail for Parkinson's? Imagine being able to detect Parkinson's disease long before the first tremor or stiffness appears. That's exactly what biomarkers could do. They are biological signs that tell us about what's happening inside the body at a molecular level. For Parkinson's disease, biomarkers are considered the holy grail because they could revolutionize how we diagnose, monitor, and treat this complex condition. Right now, doctors mainly relying on observing symptoms like tremors, slow movements, or balance issues. But these signs often show up only after significant brain damage has already occurred. Biomarkers could change that by revealing the disease's presence much earlier, even before symptoms start, giving us a chance to intervene sooner. One of the biggest breakthroughs in Parkinson's research has been discovering biomarkers that detect abnormal alpha-synuclein protein in the nervous system. This protein tends to misfold and clump together, damaging neurons and leading to the motor and non-motor symptoms we associate with Parkinson's. Scientists have developed tests like the alpha-synuclein seeding amplification assay that can identify these abnormal protein aggregates in spinal fluid and blood with high accuracy. This means we can potentially diagnose Parkinson's in living patients before the classic symptoms appear, especially in people at high risk or in premotor stages, such as those with REM sleep behavior disorder. Biomarkers are also powerful tools for tracking how the disease progresses over time. Recent advances include blood tests that measure multiple proteins reflecting the molecular changes happening in early Parkinson's. These blood panels can even predict the onset of motor symptoms years in advance and help doctors monitor how the disease evolves. This kind of objective measurement is crucial because it allows for more precise management of the disease and helps evaluate how well treatments are working. Another exciting aspect of biomarkers is their ability to help us understand the diversity within Parkinson's disease. It turns out that Parkinson's is not the same for everyone. Some people progress faster, others have more non-motor symptoms, and the underlying biology can vary widely. Biomarkers can identify these differences, allowing researchers and clinicians to classify patients into subgroups based on their specific biological profiles. This is a big step toward personalized medicine, where treatments can be tailored to each person's unique disease process. It also improves the design of clinical trials by selecting participants who are most likely to benefit from targeted therapies, speeding up the development of disease-modifying treatments. While there is still no cure for Parkinson's, the promise of biomarkers is that they could lead us to more effective, individualized therapies. They could help us detect the disease early, monitor its progression objectively, and identify the best treatment options for each person. Biomarkers also make clinical trials more efficient by providing measurable biological evidence of how a treatment affects the disease, rather than relying solely on slow-changing symptoms. In summary, biomarkers are considered the holy grail for Parkinson's because they hold the potential to transform how we understand, diagnose, and treat this disease. They could enable earlier detection, more precise monitoring, better patient stratification, and faster development of new therapies. Although the field is still evolving and more research is needed to validate these tools for routine clinical use, the progress so far offers hope for a future where Parkinson's can be managed more effectively and perhaps even prevented. As always, anyone concerned about Parkinson's should consult healthcare professionals for personalized advice and care.